Alright, today I'm going to be demonstrating how to operate two MEP002A generators in parallel. My procedure is going to be exactly the same for the 003A. Now, I see a lot of people ask the question, can I wire my two MEPs together in parallel to provide double the output? And I see answers all across the board. Sometimes people say no, sometimes yes. I'm going to demonstrate today. The answer is definitely yes, it is possible to do it. Now the 004A and above generators actually have provisions for parallel operation built right into them. They have paralleling sockets and lights, and they have the ability to run the voltage regulator in a master and a slave mode, so that just one generator is controlling both voltage regulators. Now the 002A and 3A don't have this feature built in. This actually makes paralleling them a little bit more difficult. Now because of this, we need to make sure that both generators are set up exactly the same. The frequency and voltage meters on the generators are notoriously inaccurate, and even if they were accurate, it's too difficult to read down to the volt on the generator. So it is very important that you set up both generators with a digital voltmeter first, and we're going to operate based off of the readings on the digital voltmeter, not based on the analog meters on the generator itself. Now the advantage to doing this is obviously you get double the output when you have two generators running in parallel. I have a perfect example of this. In my shop here, I have a single phase air compressor. It has a 7.5 horse motor on it, and a single MEP002A is just not capable of running it. When I turn the air compressor on, the generator is overloaded for a second or two, and then the breaker trips. Sometimes it trips instantly. And the MEP002A is just not enough generator to run that air compressor. However, when I have two of them running in parallel, they have no problem with it. And I've actually found that two MEP002As running in parallel will handle starting surges far better than a single MEP003 will. There's lots of things that go into this paralleling, and I could talk about them all day. I could talk about the difference between real and reactive load and circulating currents and apparent load and everything else, but we're not going to do that. I'm just going to demonstrate the actual procedure for paralleling the generators, and it does work. I'll go ahead and fire up my air compressor on a single generator and show you what happens, and then we'll parallel the two generators together and put the same load on them. We'll fire up the same air compressor, and I'll show you that the generators actually have no problem with it. As you can see right here, I've got cables running between the L1, L3, and L0, running from one generator to the other one. Now the other thing we're going to need for this is a good digital voltmeter. And I got mine right here. The reason for this is that we need the two generators to have exactly the same voltage and frequency. And really the analog meters that are on these generators are not very accurate. I rarely see them that are accurate to within even several volts and hertz. So when we set these generators up, we're actually going to set them up based on the voltmeter readings and not on the readings on the actual generator's meter panels. And the other thing we need for this is actually some way to indicate whether or not the two generators are in phase or not. And what I've built right here is it's a poor man's phase indicator. And what this is a 240 volt light bulb. They're pretty easy to find just anywhere online. And then I have two power cords coming out of this, and one plugs into each generator into their convenience receptacles. And when the generators are exactly out of phase, the light will be receiving a full 240 volts. When they're in phase, it will be receiving 0 volts, so it'll actually be out. And we're going to use this to indicate whether or not the generator is in phase. And I'll go ahead and fire up the generators, and we'll show you how this actually works. And I'll hook up my oscilloscope too, so you actually get a visual of what the generators are putting out. And you'll actually see the waveforms when the light lights up and goes out. Okay, as you can see right here, I have my poor man's phase indicator and my oscilloscope going. And the two waveforms you see on the oscilloscope are from the two generators. One's operating at a slightly higher frequency than the other one. And as you can see, when the two voltages are actually completely in phase, the light is completely out. When the voltages are exactly out of phase, the light's at its brightest. Now our goal is to close the breakers on the generators when the voltages are exactly in phase. Now if we close the breaker too early or too late, we'll cause a large current spike and we will likely trip the breaker on one or both of the generators. So this light is our indicator for that. When the light is completely out, that's exactly when we want to close the main breaker.